Hello and welcome to Bali, Indonesia. I'm gonna do a small tour of my production facility here in Gaia Regency in Bali. The Light Forge is located in a very green area. There's a lot of villages around. For those of you who don't know how rice grows, this is how it grows. This rice behind me, it's gonna be harvested in about a week. It takes about 2 months to grow for the cycle. For one cycle to grow, and then the fields rest for like 2-3 months and then it grows again. But let's return to the facility. So this is where I'm located, in the middle of the nature. Back in 2023 in June, I found this small house that was for rent by one of the previous business owners that had a salon here. It's a very small house, but it wasn't enough to house all the equipment, so I had to get the house and invest some money. Total, I invested $70,000 into this facility and construct on the place of a garden. I had to make a kind of a garage. On Bali, people move on bikes. This is my bike. Everybody moves on bikes here because it's always warm. So we're entering the space. This is the garage area. This is Donna making a ceremony, morning ceremony.
Hi.
So this facility was not here. It was a garden. The space is about 9 by 6 meters, and it houses the main piece of equipment. I had to raise it from scratch. There was no floors, there was no roof. What you see behind me is the wall of the house. You see on the back of the house there is electrical meter. That's the new one. So I had to build everything, the roof, the new walls, the floors. I had to learn the electrical code, which took me about 3 weeks, maybe a month, and even do this whole thing myself. This is all done by US standards. I have a 3-meter grounding rod. I have a 10 kVA voltage stabilizer, because without it, the equipment, it's very expensive equipment, so the voltage is spiking here on Bali very significantly. With the 220 volts, it can spike down to 130 down and 50 to 60 up. So if you don't have the voltage stabilizer, you can be in trouble. The main piece of equipment is the laser machine, which is 130 watts, 2 laser heads. That's how the CO2 laser tubes look like. It's a very complicated piece of equipment. It took me about 2 months to arrange the whole deal with China factory to get it here. This machine with import the cost was about $15,000 with import, but if you buy something like this on Bali, it would cost about 30 to 35,000. So the fact that you can arrange something like this and actually calibrate it, it saves you thousands of dollars. It took me about 2 weeks to calibrate this. The calibration of a laser machine is it's like a riddle about parallelism. Basically, you have to parallel 2 beams of laser through 3 mirrors and get it to the 2 heads. The size of the machine is 1.6 by 1 meter. These are the 2 heads, and mainly I use it for cutting and engraving something like this. These are small pieces from the leftovers. It can engrave on plywood, it can engrave on acrylic. It can cut acrylic up to, I think, 12 millimeters and plywood up to 10 to 12 millimeters. All this behind me is the equipment that I used to build this place. I had to learn how to weld. I have saws here, how to work with wood. And then it took me about 2 weeks to construct this shelf. For those of you that have small shops or do manufacturing, there is a big problem with warping of the materials, especially when you work with wood or you work with acrylic. You have to keep the material flat, something that creates a big problem for manufacturers, because if it's not flat and you put it on a laser, you have to somehow fix it to the bedding, because the focus distance changes, and that prevents cutting or engraving in a consistent manner. So all the materials have to be kept flat always, and the shelf has to be very it's an engineering piece of art, I would say. I mean, it looks simple, but this shelf can hold from 5, maybe 6 tons of material, because each sheet of acrylic or plywood usually weighs around 18 to 22 kilograms. So when you work long term and of course you stock, in bigger quantities to get the discounts, you have to keep all this somewhere. In addition, this shelf was made to be as a help for the laser app operator. I designed it in a way, when I was ordering the laser machine, I made sure that it comes with a back hole, so you can feed it. So the shelf number 4 can feed the laser, so it's operatable only by one person. Then this is the chiller that chills the laser tubes. When you turn it on, this is like a big freezer. The water goes through the laser tubes here, and when the laser is operational, it has to be chilled. You see it? And then there is a vacuum system. This pipe that goes on top has a big, huge ass fan on the roof that sucks out all the fumes when the laser machine is operating. It has 2 exhausts right here. When you put something that's burning, it's actually going to be sucking out let me show you. It's actually pretty powerful. It took me about a week to install all this system. Basically, the laser installation, preparation, all in all, with calibration, getting this thing in here, it weighs around 600 kilograms. It took about 2 days to install it. 6 people to get it in here. It couldn't get through the door, so we had to put it on the side. It was a whole fucking mission. Look, see. So this is one of the main piece of equipment in the workshop. Then these are the pyramids, and this is how the assembly looks like. It might look pretty simple, but it's pretty complicated. Trust me, it takes about 3 days to assemble one set, and it's divided into 4 pieces. The base is actually made, let me get These are the defective parts. So the first part is in manufacturing is actually making the base. The base is made on 3D printer. Before I started this whole journey, I wanted to optimize the process and make a mold, but the mold companies told me that it's so complicated that they cannot make a mold, so I had to stick with the 3D printer because the model, let me find where I have the parts. You see these parts, these are leftovers. I have black, and the base is made from 4 pieces like that are made on 3D printer. And it took me about 4 months to get this model to perfection. It got holes for the sound, it got holes, special holes for the LEDs, screws, assembly. So when you put this 4 together like this, you see, you get the what you call the pyramid base. It looks like this. It's a very complicated model with a very high precision, 1/10 of a millimeter. The hardest thing in the model was to make it assemblable and exact. The problem with the resin 3D printer that I'm going to show you next is that when you work with resin, when you work with plastic has a tendency to shrink, and it's not stable. So you have to stabilize it, or you have to print with the knowledge how far it's going to shrink, because the model is designed in fusion, CAD fusion. And imagine when you design everything with precision, where parts have to be put together with the screws, you have to make sure that when you print several parts, the screw holes will actually match each other. And then you have holes right here. You have holes for the magnets. And then you have here the glass that has holes as well, that is made on the laser. So everything has to match. These screws here that hold the bottom, I'm not sure if it's visible, but there are about 24, maybe 30 screws, so every hole has to fit perfectly, match perfectly with the part that it's gonna attach to. And 3D printing something like that, to stabilize it, to make it, to bring it to manufacturing level, took me about 2 to 3 months. There are a lot of defects, and some of you that do 3D printing might look at the model, and in my previous video I told you that the one set, the cost of just material of one set is $400. So when you look at this model, those of you who are in 3D printing, it might not look that way. And I actually thought the same way when I was originally planning the production. I thought that the cost of one pyramid would be about $50, not 200. But then once you start dealing with you start doing accounting on batch basis, you realize that there are so many defects, there are so many things that you could not account for, that eventually the costs are X4. I didn't account for a lot of things, for a lot of defects with even with laser cutting. For example, when you do laser cutting of some of the parts, you see the parts, there is always a waste. So all this waste is in the beginning, when you start and you don't have experience with manufacturing, it's hard to account for. And then there are defects. Sometimes during the manufacturing process, the laser stops, the electricity shuts down, something happens that screws up the whole production process, and you have to, for example, take another sheet, and each sheet costs, let's say, from 50 to $100. So to learn to fine-tune all these processes, it takes enormous, well, not enormous, but let's say thousands of dollars that were not originally accounted for. When the base is assembled, these are the bases that are in process of assembly. That's how it looks like. These are already assembled bases. These are preparations of the engraved bases. You see there is the side, there's the gold side, then there is the bottom side. This gold acrylic, it's actually pretty hard to work with. It comes, the reason it's hard to work with because it's very fragile. The backside of the acrylic, it's actually special material that creates the mirror effect. So when you work with it, you have to be very careful because the scratches on the back create the defects on the front side. Then there is electronics. There is a lot of defective electronics. Some of the chips that I order, these are the chips that I use. Let me show you. These are the CPUs. As I mentioned, these are ESPs, CPUs, small CPUs. I've already developed my own chip, but I haven't started production yet. I'm gonna start production probably next year once I get enough orders, because I have to order minimum, I think, 500 chips to actually make it worthwhile. So instead of making the assembly from all these parts that you see here, you see there is a lot of parts. So it's about 6 parts that have to be connected. There is the actual chip, the CPU, and there are 2 voltage converters. Then there is a decoy. This is the one that creates, makes possible the USB-C connection. It converts, it communicates with the USB-C port adapter and tells them that it needs to be tuned, for example, for 12 volts or 5 volts or 24 volts. Then there is the microphone. The microphone has to be soldered manually, and it's, I mean, it takes, it's a lot of time to actually solder everything together. So there is microphone, there is a small button. The button allows, on the bottom there is a reset button here. Not sure if it's visible, but there is a small reset button, small hole, so in case something goes wrong, you can hold the button for like 9 seconds or 6 seconds, and the chip resets to factory defaults. So there is microphone, there is chip, there is decoy, there are 2 voltage converters, there is microchip, and then there are connectors to the chip, and then there are LED strips. I ordered very high quality LED strips. It looks like normal LEDs that you see anywhere, but the thing is that it's not normal. These are not normal LEDs. I actually had to go through several suppliers throughout several years to find very high quality, high contrast LEDs. And then when you start manufacturing, there is another problem. You see that when you do it for yourself and you do tinkering at home, you can replace anything. Something doesn't work, you just take it apart, you replace it, and you put it back. But when you're working for like you're creating something, you actually have to make sure that the defect rate is low, because you don't want to send people something that's going to be defective. So I had to find a supplier that had the lowest possible defect rate, which is under 1%, which is like unbelievably low for the, you know, for the industry. And then it's very high contrast LEDs that allow very smooth transition of the light when you work with the WLED, which is the software. Then there is the small parts. You see these small things that have to be, these are tapes, glue tapes. In the assembly there are a lot of small parts that require so much attention that I couldn't even account for this when I was originally making this. So I had to find suppliers for each small piece. There is this small tape you see along this edge, the black one, and then there is this tape. So you have to find a supplier for every small piece, and some of the suppliers are hard to not to work, but it's impossible to order small amounts. So otherwise it just doesn't, it doesn't make sense, especially when you're starting. You have to find suppliers that are willing to work with you with the very low minimum order quantities. So the next one, this is my workstation. This was the first original, the Sri Yantra that I told you. This is what I started from 5 years ago. No, not five, sorry. In 2016, when I originally founded the company, this was the first product that I launched on Amazon, and that got me started. This was the Sri Yantras 13.5 centimeters, 13.5 inches, 34 centimeters, and I had 10 colors of them. All colors of the rainbow: silver, gold, and bronze. So next I'm gonna show you the 3D printing room. I think I showed it to you yesterday, but during daylight it's gonna look maybe different. This is the 3D printing room. That's where the plastic parts are produced, the ones that I showed you. These parts, this is all the defective parts. This is how many, this not all the defective, there was much more. It's probably like 1/5 of the defects. These are the calibrators that I use to calibrate the 3D printers. For 3D printers I use two frozen. One is frozen Sonic Mega 8K. It uses resin and it pulls the part from this resin upside down, for those of you that are not familiar with the 3D printing. And the second is also frozen, but it's frozen Sonic Mega 8KS. It's a little bit smaller. The height is, instead of 40 centimeters, it's 30 centimeters. And I had to build this room to make sure that it's completely sealed from the air, because when you do production of plastic, you actually have to account for the temperature. So it's fully temperature controlled, because if you lower or increase temperature even by sometimes 1 degree, you get a lot of defects. So that accounts for another hundreds of dollars. Sometimes you lose $50, $100 a day just by mass producing, by trying to figure out the correct ratio or correct temperature or correct settings for the 3D printer to make sure that the model is dimensionally stable and it doesn't warp. Again, when you do it for your own, like for your own home, for your own needs, it's not a big deal. But once there is a task to actually make like 10 or like 20 or 30 of something, you realize that it takes so much time that you better optimize once and then proceed with the, with producing the 20 or 30 or 50. You see, this is the defective part as well. A lot of defects here. Mask. Once the part is done, it goes through cleaning process, goes through alcohol. Number 1 cleaning container, number 2, and then it goes into this cleaner. It has 2 turbines on the inside. Once the part is cleaned, it goes into this UV chamber, custom UV chamber. And then it takes another, even after the UV chamber, it takes another 2, sometimes 3 days for the part to get stabilized. This is the parts that we use for the assembly. The glass. See these pieces of glass? It takes sometimes hours to clean this when you work with laser and when you actually do the engraving of the very intricate small parts like this. To clean the paper from the acrylic, it takes enormous amount of effort, and then well, basically every step in production is, I mean, it takes weeks to figure out how to do it correctly and to fine-tune the processes. That's why it took me. And when I finished the construction of the Light Forge, when I finished the prototype in the end of 2023, and it was the first prototype actually was ready at New Year's Eve of 2024. And even after that, since I had already had orders from all over the world, I had to fine-tune the production processes, and it took me another about 2 to 3 months in addition from November. Well, in all, it takes, I think, about half a year to fine-tune all the processes to make sure that I can produce that in 3 days. I can probably cut it to 2 days soon, but at the moment it takes about 3 days to produce one set. Then one second, let me put it back and I'll show you something else. This is glass for the, you see, glass for the pyramids. Then there are magnets. The magnets was the most painful of all the production. Imagine I had already orders and I didn't know how to make this thing fit in the box. I mean, you cannot use screws because the assembly is going to be too complicated, and the product that you sell, you want it to be as easy for assembly as possible. So I didn't know what to use. I couldn't use screws. Without the screws, I had inserts first. The glass was inserting like this. It had inserts at the bottom. There were no magnets. You just insert it. But when you insert it like that, the top of the pyramid was like, I mean, it wasn't straight. So eventually I came up with the magnets, but there was a big problem with the magnets. I ordered 25,000 magnets from I found the best supplier in Ningbo province in China. That's the biggest location of the neodymium magnet production. And I found a supplier that produces magnets for Apple. So the error for each magnet, they send me a sheet of error factor for each magnet, and the error factor for each magnet is tenths of a millimeter. So the magnets look like this. You see, the magnets are 3 by 3 millimeters. I use 3 by 3 millimeters and 2 by 3 millimeters. The diameter of the magnets is always 3 millimeters, and some of them are 2 milli in height, and some of them is 3 milli in height. Depends on the placement. The 2 milli I use for the basement to put it inside in here. These are 2 millis. And then for the glass, since the glass is 3 millimeters, these magnets 1, 2, 3, 4, 5 for each glass, there are 3 millis thickness. So each magnet holds this small magnet, you won't believe it, but each magnet 3 by 3 milli, 3 milli in diameter and 3 in depth, it holds 0.36 kilo. That's how strong they are. The one that at 2 by 3 millis, I think it's about 2.25 kilo. So it's pretty amazing, and they hold charge for 300 years. If you do research, or if you like, some amazing stuff, Google neodymium magnets, you'll be surprised what they do and what kind of technologies have been developed with these magnets. So the problem with the magnets was I could not insert them into the acrylic glass. So I had to design a special insert that I insert into the hole into the acrylic glass. Insert which looks like this. This is a silicone cap, custom made. I had to make a model and ordered 25,000 of those too. So this silicone cap, if you put it like this, it holds exactly, it's the same diameter. The walls are 0.5 of a millimeter, and the cap, you see, the cap is supposed to be inserted into the glass and then hold the magnet. But guess what? The cap is actually silicone, and the magnet power, when it's been attached to another magnet, the power is so big that it's not holding, it's getting out from the holder, like this. Like, I mean, it's not holding. So basically nothing worked, and the problem was how to hold the magnet in place. So I asked my partners what could be done. They told me go with glue. But the problem is that these magnets are covered with what's the name? NiCad, Nidium. There is a material. There is actually, the magnets are covered with a special like metal. So this metal with silicone or with acrylic, it's impossible to find the glue. I went through like 20 different glues. I googled online, I went through all possible options. Then I found a couple glues, but it turned out that the glue was leaving residue on the acrylic. So I imagine how I'm gonna be putting 5x4 20 magnets into 4 sides, and then divide the times two pyramids. That's 40 magnets per each set. And I realized that it's gonna be a mess. It's gonna look like shit. So we cannot use glue. And then something came to my mind. I figured that the only way to hold the magnet is actually hold it with the force instead of glue. And I actually had to print my own holders instead of ordering in a factory. I printed it using the 3D printer. This I discovered this by thinking the following way. I couldn't insert the magnets into the acrylic, so I thought, why can I insert the magnets into here? You see this parts, they have magnets here that hold the glass. So I thought, if I can insert it into plastic, that means the plastic, I mean, it's expandable. The plastic expands, and it can contract. So basically you can squeeze in the magnet and it's gonna be holding. So I said, I need some kind of damper between magnet and the acrylic glass, which is this. See? There's a magnet, but there is no cap, it's just a tube. So I said, let me try to develop and to 3D print the tube. So what I ended up doing, I ended up printing this. You see this tube? So you insert this into acrylic, and then you squeeze in the magnet. Not the squeezing, I mean you push in the magnet into this, and it actually holds. But you have to make sure that when you 3D print and when you cut holes in acrylic, you have to know exactly what the dimensions are. Imagine when you're working with a laser, those of you who've been doing manufacturing, and when you do small parts, especially like in millimeters, you have to account for what's called the curve. The curve is the thickness of the laser beam. So let's say you're cutting a hole in acrylic which is 3 millimeters. If you don't account for the curve, the laser, depending on your calibration, the laser thickness can be 0.1 to 0.2 millimeters. And if you take, for instance, this 3 millimeter hole, and you have a task to insert 3 mm diameter magnet into a hole, you have to account for this thickness, you have to account for the laser beam thickness, and also you have to account for the contraction of the plastic when it's fully cured in 2 or 3 days. And then there's another factor when you 3D print, depending on the exposure time of the UV ultraviolet light, the thickness of the walls that you design in a 3D model program might be different by might vary by 0.1 to 0.15 of a millimeter. And when you off by more than 0.1 or 0.15 of a millimeter, your magnet is not going to be inserted into the hole. It's going to be impossible to squeeze it, or if you squeeze it, it's going to crack the glass. You see the problem? So there is like 5 variables, and when one variable is off, when your equipment is off, when something wrong is with another equipment, or you don't account for at least one variable, the whole production process, it's not working out. So I had to fine-tune the holes and the materials to precision of a hundredth of a millimeter to actually make these things attach to each other in a perfect way that you see it here. The problem with the magnets, besides being elegant and making it elegant, is the following. When you start shipping this product all over the world, the size of this is 28 centimeters. The height, I think it's about 17, I forgot for sure, but imagine 2 pyramids unassembled. This is called volumetric weight. So you're going to be paying hundreds of dollars just for shipping. I mean, right now I have DHL contract. Usually it costs about $100 per kilo, but I have a contract that they give me from $80 to $140 for 5 kilos. So I'm on a I'm communicating with a very nice representative that gave me the best rates possible. So it would be actually even possible to ship this all over the world. But if I wouldn't account for if I wouldn't be able to assemble this, disassemble, the whole mission of shipping this and producing would be, just one small detail would make this impossible for shipping to the world. So the whole assembly task was the most important one, and it became the most elegant. The magnets are so powerful that when you see, take this, there are 4 magnets on the bottom, there is 1 magnet on top. The top magnet is actually, there is this thing, I had to design this thing too, there is 4 magnets, and it holds the 4 nexus points of the pyramid. Even if you put the glass without the top alone, it's still gonna hold. That's how powerful the magnets are. Look, I'll disassemble this and take this out. The last one, see? The glass is held by itself without, just by 4 magnets. See? And it's impossible to account for the perfect angle here. You see, it's going to be always different, even when I did the inserts. But if it's off even by 0.1 degree, it's not, these tops are not going to be held, they're not going to be attached. So I had to, it took me another couple of weeks, or maybe 3, long time to develop this technology, this piece that holds the magnets. And then these magnets had to be incorporated also in harmony with the design. You see, so they won't be too visible. It had to be without the glue, they had to be pressed. There's a whole production process of pressing the magnets. I have a separate, like, a guy that, a freelancer that comes, that helps me with the soldering, the cleaning glass, and pushing the magnets. And then you saw Donna here. Donna is my #1 help, my manager that saves my life. She's doing ceremony. She's Indonesian, and she does everything same as me. Cleaning, pressing magnets. I taught her how to work partially with the laser. I mean, everything. And I had a separate person for 3D printing as well. But before that, of course, I was doing everything myself. Sometimes I still do everything myself, but most of the time, right now I have freelancers coming and helping me. You see this silicone, I never used them. So I made an order, but it didn't work out. So again, the magnets are, it's a trip. It's a very big trip with the magnets. Then there is, I'm not even getting into programming yet. I mean, it took me about half a year to fine-tune the programming. You see that the software that I use is open source. Most of you maybe who work with electronics or something like that know what is WLED. You install it on this chip. It's an ESP32 chip, and it's very easy. Well, everything is easy when you know it to install, but there is another thing. It's easy when you know programming. So when I was started working with the ESP32, I first originally learned Arduino language. Well, Arduino is partially C++. I mean, it's C++. But when you go into ESP32, you actually have to know what you're installing. So to read the WLED and to install it with the factory defaults, you have to know C++. So I had to learn the language just to make sure that I know what I'm installing and to make this whole thing work. So when you press in that button that I was telling you about, the reset button, it resets to the factory default that are actually tuned inside the software by a person who has to know programming, who has to reverse engineer in a way the software that is open source that's been developed for throughout, like, I think 10 years. There's a bunch of guys in US. No, it's not only United States. I think there internationally is somebody from Europe, but those guys are like, they do a very big service to the tinkering community by supporting, by upgrading the software and making it very, very user-friendly. The software is actually one of the main things that makes it very attractable is the sound reactive feature. The pyramids are sound reactive. There is a bunch of presets, and you can do some magical stuff with music. For those of you that will figure out how to connect it to Wi-Fi, which is not hard, but I know some people are lazy and they just don't want to get their hands dirty with the Wi-Fi connection and the Bluetooth connection. They just prefer to get the unit and just plug it in, and it's going to be working by itself. Well, I did that. It actually does that. If you don't want to connect it to Wi-Fi, you can actually do that. But if you figure out how to connect it to Wi-Fi, which takes about a minute or two, you will be able to get yourself into the world of sound reactivity, which is pretty magical. It takes some time to get to know the software and to learn how to configure, the sound reactive feature. But once you do, your life's gonna be much more fun with it. So what else I wanted to show you? The box. You see these boxes? These are the units these are actually fully assembled, and there is, I think I got about 10 or 12 that are still in assembly. So this is all that is left over from the first batch that I originally started in December last year. So these units, 10 units are ready for shipment before December 5th for Christmas. And I got another 12 that can be shipped in December. Then I'm pretty much out of stock, and I'll have to get back into production. These boxes that you see, I used to live in Miami for 19 years, and the boats I used to have spend a lot of time on the boat. A lot of my friends had boats, so lots of boats have teak wood as the flooring. It's considered very strong wood. It doesn't rot, it doesn't get eaten by any bugs, and it's a luxury wood. But it turned out that in Bali, Indonesia, I'm sorry, not in Bali, but in general Indonesia, teak wood is actually very unique. It's beautiful. It has a very beautiful pattern. You see. So these boxes are custom made by my supplier, one-man army, you can call it here. It takes him about 1 day to make one box, but he told me if he needs more, he can hire some additional people. So I produce boxes here. It's very strong. I've already tested shipping with DHL Express all over the world, and they survive. I mean, to say the least. Survive is actually, they survive very good. The box, to design a box took me about 1.5 months. Yeah, everything has to take time to design this. I didn't design this. They showed me up there what has to be done in terms of designs, so I just put it together, added some colors, and that's it. So these are two pyramids. There's yin yang, Ra pyramid, Gaia pyramid, and then there is a DNA spiral. So when you open the box, it's very safe. It's very safe packaging. The material, which is PE foam, I ordered it here. I use laser to cut it. You see, cut it and then glue it. And this is how the inside of the box looks like. These are custom, very flexible wires. I have a supplier, my own supplier, that makes this for me. These are very strong. This has very soft coating, and they last long. It's not like, you know, phone wires that you buy and then in half a year something starts to fall apart. No, these are actually like a long term, and the length of each is 2 meters. So every detail in this is made like love, is like love, big love, because I made sure that, you know, everything is so high quality, that I'll be proud. I can stand behind my word, literally. These chargers, I had to order them. These are custom made as well, custom order. These are new technology. I actually describe it on my website. I didn't know that they have this technology up until the moment I started. I got to the point where I realized that when you buy this, not from supplier, but when you buy this like from online store locally, just one of this costs about $15. So I said, you know what, something is not right. I have to find the same quality but cheaper. I mean, because when you do orders over 100, 200, 500 pieces, you're supposed to get discount. But if you get it from like retail supplier, of course they put the margin. So I had to find a separate supplier that produce this, and they use GaN technology. This is a new technology. No, it's not silicone. It means that the form factor is very small, and they can pass 30 watts, which is amazing for that size. It's very light, and it's very stable. Then there is these two small pieces packed here. This triangle holders, and then there is glass. Let me take this. You can use this. This is one pyramid. It's packed. Let me use the another hand. It's all packaged in gloves. You see, to make sure that the acrylic is not touched. And then there is this second Gaia at the bottom. So that's the box you see, and this I think 1 millimeter, I'm sorry, 1 centimeter box. The walls of the PE foam, they're 1 centimeter thickness. When you travel, and I travel with them a lot, it takes about 2 to 3 minutes to put the whole set on your table and connect it. And when you have to go like package them back, it takes the same amount of time. So even the wires, let me show you this, even the wires and the space for the wires is made in a way that you don't have to like think how you package it. What I mean is, you see this space for the wires. When you take your hand and you need to put this back together, you take wire and you just roll it around your hand. And when you roll it around your hand, you can just squeeze it and put it here, and it's gonna fit perfectly. I mean, small details like that matter when you travel with them, when you unpack them, like, you know, in an Airbnb house, when you go to the beach. Basically, it's small details everywhere. Then there is another thing. Since they're equipped with the USB-C, and they have a decoy, that's a special microchip that reads from the this thing can feed up to 24 volts depending on the requirement of the device. The decoy is a device that tells this adapter how many volts it needs. It's a USB-C technology, which allows different devices to get different voltage from the charger. It's called power delivery technology. For those of you that don't know, it's PD, power delivery. So since I use this to feed power, you can actually use power banks with USB-Cs to power the pyramids. That means that you can take them anywhere with you, to the beach, to the parties. And if you have a power bank with 20,000, I think 20,000, there are 10,000, 20,000, 30,000. The 20,000s usually have 2 USB-C ports. That means you can power the pyramids anywhere that you take them. And 20,000 watt hours power bank is gonna be able to power them on average, I think, from 6 to 10 hours, depending on the presets that you use and depending on the brightness that you use. The reason I didn't put battery inside the pyramids, which is it's pretty easy, but that's not the issue. The main issue is with the shipping. Once you start shipping packages, there is this question that many couriers ask you if there is a battery inside the device, because it's dangerous chemicals that are inside the battery, and when they're transported with the airplane, they have a possibility of blowing up. So battery issues are very very sensitive when you want to ship your products all over the world. So I designed it in a way that it's powerable by power bank, but there is no battery inside. Plus the weight of the product would be, I mean, not much, but it would be more. It probably would take another 300 grams, maybe 400 grams, 200 grams per each battery. But that's not the point. The point is that it would stop me from shipping it to some countries and use some couriers. So that's pretty much it. I think the magnets, the plastic, the LEDs, the microchip. I developed a separate microchip. I think I didn't finish explaining this. The separate microchip that contains all this 1, 2, 3, 4, 5, 6 in one chip, and it has the ports, special ports that you just connect the LEDs to it. So the assembly is going to be much easier, but I need more orders because the minimum quantity to get this whole production going is 500, and at the moment I don't have 500 orders. I'm sorry. I'm moving there, but once I get not even 500, but at least like I need to get to like 50, maybe 100 to get this thing going. Probably 100, because with the new price drop right now, things are gonna be moving hopefully easier. People are gonna be understanding that I'm not making money on this. I'm just passing this to you, this good stuff to your house. $135 even to make 3,000. I need to sell what? 135 divided by, I need to sell like 20 units. 20 units, and that's a lot of work for 20 units. But that actually makes me happy, because I'm gonna be optimizing a lot of processes. I'm planning to order another separate laser machine that's gonna be engraving about 100 times faster than my current machine, because the current laser, it's actually made primarily for cutting. Once you start engraving, since the laser heads use the axis, like the bridge, to move, it takes about 10 minutes to engrave one piece of glass, imagine. So it takes 40 minutes to get engraving for one pyramid. For this, so 10 minutes, 10 minutes, 10, 10, 10 minutes, 10, 10, 10. So that's 180 minutes. That's 1 hour, 20 minutes to get the engraving just for the glass. And then it takes another, I think, 15 or 20 minutes to engrave this side, the Shipibo pattern. And there's another 10 minutes to engrave the Egyptian pattern. And then for the facades, it takes about, I think, 5 minutes for the whole thing, 5 minutes for the whole thing. So to get the whole set engraved, it takes 1 hour 20. It's about 2 hours. That's with cutting. But if I could just cut it on this machine, since it uses, you see the engraving is really slow. But there are machines that use different technology for the engraving, and they can engrave literally 100 times faster. The cost of the machine, I think it's about 5,000, and then the import is gonna take me about probably a month, maybe 1.5 months to import it, and with taxes and imports it's gonna cost me about $7,000 just to optimize one process. But once I optimize this process, I can reduce the production time, and as I was saying in my previous video, I can pass the savings to you, because all the savings that I'm going to be getting from my suppliers, I intend to pass it onto the price tag, so to speak. What else? I think that's pretty much it. I covered plastics, I covered electronics, LEDs, decoys, microcontrollers, the programming, acrylic, and I mentioned in my previous video that I received an advice from there that I am willing to share, to make this affordable, to share with people that want to produce the light portals. And the only requirement for the franchise is the 10% fee from your sales. That's it.